Here's our warm-up. It says, how do the graphs of the following equations differ? So if I graphed these two equations, how would they be different? Which one?
Like the second one, you'd at least move 5 to the right.
Okay, so we know the second one, because of this minus 5, is going to move 5 units in some direction. Yeah, that 5 causes this to be 5 units below or down. I'm going to say below the first graph. So it'll have the same shape, but the second one will just be 5 units below the first one, and I know that's the case because there's a minus 5 on the end. What are your questions on this warm-up? All right, we are talking about complex numbers today. This is section 5.4. Your goal today is to solve quadratic equations with complex solutions and to perform operations with complex numbers. Very exciting stuff. All right, so the first thing we're going to talk about today is what is an imaginary number. An imaginary number, we note it using the lowercase letter I. I equals the square root of -1. So yesterday on your quiz, you actually had a problem where you would have got a negative number under a square root. I had you change the problem, though, so you wouldn't end up like that. If you ever have a negative number under a square root, it gives you some problems because no number times itself could give you a negative number. So, for example, if we had the square root of, let's just say, -16 or something. Is there any number times itself that would give you -16? No, because -4 times -4 is positive 16. And of course, 4 times 4 is also positive 16. So it's impossible to get a negative number by squaring another number. That's where I comes in, okay? I helps us answer or simplify radicals that look like this. Any questions on that? All right, so here's our first example. I'm actually going to write all 3 examples before we start. So instead of thinking of this as the square root of -9, I want you to think of it as the square root of -1 times the square root of 9. Everyone agree with what I just wrote? Okay? Do you guys know the square root of 9? 3. Do we know the square root of -1? I. We just learned that. So the square root of -9, we say, is 3i. Any questions on that idea? All right, another way to think of the square root of -121 is the square root of -1 times the square root of 121. Everyone agree with that step? What is the square root of 121? 11. What's the square root of -1? I. So this is 11i. Yep. Yeah, so anytime you get a negative in the square root, you could just say I. So you could definitely jump from this one to this one. We know the square root of 121 is 11. We know the negative is going to give us an I. So there we go. All right, this one is kind of tricky. I want to actually write this one out. So what did we already learn that I is? I equals what? Square root of -1 squared. Square roots and squares undo each other, correct? So I squared just gives us the number -1. That is extremely important. So I'm going to make us some notes off to the side on the chalkboard here. I is the square root of -1. I squared is just -1. That's going to come in handy later. What are your questions on this? Kind of a different concept. Alright, so we are going to use what we just learned about I and square roots of negative numbers to solve these two equations. So on number 1, I have x squared equals negative 16. How would I get x by itself here? Take the square root of both sides. So right now, you have x equals, remember you have to do the plus or minus, the square root of negative 16. What is the square root of negative 16? 4i. Good. So the answer here is plus or minus 4i. How would you, yes? Okay. How would you solve number 2? Divide both sides by 5 first. So you get y squared equals negative 8. Then what? Square root and square root. So right now I have y equals plus or minus the square root of negative 8. This one's kind of tricky. I know I'm going to have an I, right? So let me just take care of that right now. So this is going to be plus or minus I square root 8. I just took the negative sign out because I know that's going to give me the I. Now how do you find the square root of 8? Factor tree. So this is going to be 2 and 4, 2 and 2. So I'll have a 2 out front. Then I'll have my I, then I'll have my square root of 2. Now, order isn't like overly important here. If you had plus I times 2, square root of 2, I would know what you mean. I we usually treat as a variable though, so when you have a coefficient with it, you put in front of the I. So 2I square root of 2. Alright, how am I going to start number 3? Add 4, good. So I have r squared equals negative 4. Square root. Anytime you take the square root, you have to introduce the plus and minus. Yeah, so what is this going to equal? 2i, very good. Kind of an easier one. Make sure you have the plus or minus. When people start to introduce the I concept, they kind of forget the easy stuff. So make sure you have the plus or minus here. Questions? All right, let's do number 4. Add 8. So negative 2t squared equals 54. Divide both sides by negative 2, and what do you get? Negative 27. Thank you. Square root of both sides. That would give us t equals plus or minus the square root of negative 27. How am I going to find out the square root of 27? Factor tree. So that's going to be 3 and 9, 3 and 3. So let's see if we can jump to the final answer. I'm going to have plus or minus. What? 3i square root 3. Good. What questions do you have? All right, number 5. How do you want to start? Yeah, subtract 1 from both sides. So I have 3x squared equals 36 with a negative. Then what? Divide both sides by 3. Good. X squared equals negative 12. Then what? Square root. Good. So x equals, we need the plus or minus the square root of negative 12. How would I simplify the square root of negative 12? Yeah, I do 3 and 4, 2 and 2. So what do I have on the front? 2i square root 3. Don't forget your plus and minus. Questions? All right, number 6. We got to get that 25 to the other side, so I'm going to subtract it. What would my next step be? Square root, good. So y equals? Great. Easy one, plus or minus 5i. What are your questions? All right, here we're going to talk about adding and subtracting complex numbers. Here's our first example. The cool thing about this is that you treat i's just like you would treat x's. So if this was 5 plus 4x plus 7 plus 2x, what would you do? Combine like terms. We would distribute if there was a number in front of the parentheses. There's not, so technically you could distribute a 1. But I wouldn't really worry about that. I would just start combining like terms. So 5 and 7 go together to give me 12. 4i and 2i come together to give me 6i. All right, so we just had number 7, right? Sorry, the answer went away when 8 popped up. We got 12 plus 6i. Just to recap. What would you get on 8? Negative 1 plus 4i. Wonderful. Number 9 is not going to be so easy because here we do have to distribute. So I have to distribute that negative 1. So this would be I minus 5 plus 6i. So what would I end up with? Very good. I'm going to write the real number part in the front and the 7i in the back. If you put the 7i in the front minus 5, that's fine as well. I just typically put the real number part and then the imaginary part. What are your questions on this? Just a little more practice. So we distribute the negative sign here. We get 12 minus 8i minus 6 plus 6i. Again, I'm going to do the real part first. Those are just the regular numbers. So that would give me 6. Then I'm going to do the imaginary part. I'd get negative 2i. All right, do I need to do any distributing on 11? The reason I distributed on that one is because you were subtracting everything in the second set of parentheses. So if you have a negative sign or a number next to parentheses, you have to distribute it. Here, we don't have to distribute because technically you could distribute a positive 1, but that's not going to change anything. So if it's a negative or a coefficient in the front, you need to distribute. Here, though, we don't need to distribute. We can just go ahead and combine like terms. So what do you get for your real number part? 3, right? What about the imaginary part? Minus 8, right? Negative 7 and negative 1. All right, what about on number 12? Yep, we have to distribute here. Good. So that gives me 12 minus 8 plus 10i. What's 12 minus 8? 4 plus 10i. Great. Do you guys have questions on this? Again, we're going to treat I basically like we treat all other variables except for the last step. So negative 2i times 5, negative 10i. What's negative 2i times I? Good. I'm going to give everyone a second to catch up with this. Now, we know the value for I squared. It's written on the board. I squared is just negative 1. So you need to rewrite this thinking of the I squared as a negative 1. That's going to make that a positive 2. That's the tricky part with multiplication. You never want to leave it I squared. I squared has to come out on all of these. The good thing is, though, it's always just a negative 1. So once you get in the habit of getting it out of there, it's not too challenging. Any questions on number 13? All right, here's number 14. We got to distribute. What's 4i times 3? 12i, good. Minus, what's 4i times 5i? 20i squared, good. What's I squared? And what's negative 1 times negative 20? Good, so this is going to be 12i plus 20. I told you earlier I always write the real number part in the front, so if you want to rewrite it that way, 20 plus 12i, that's probably the way the back of the book will give you the answer. However, I am aware that this is exactly the same, so I'm fine with this. Any questions on this? All right, on this last one I need to double distribute. 2 times 2 is 4. 2 times negative 3i is negative 6i. 3i times 2 is plus 6i. 3i times negative 3i is minus 9i squared. What happens to that middle term? Very good. And then I have minus 9i squared. What is 9i squared? Yeah, which is what? So this is actually 4 plus 9. 13. Good. So yeah, sometimes all the i's cancel out and you're left with just a regular real number. Pretty cool. Questions on this? So I need to use what type of multiplication? Conjugate multiplication. All right, so instead of multiplying everything by 2 plus I will multiply it by 2 minus I. Good. And again, this is just to get rid of all the i's in the bottom. It's kind of like square roots. You don't want square roots in your denominator. You don't want i's in your denominator either. So on the top, distribute the 5i. That gives me 10i minus 5i squared. On the bottom, when we double distribute, we get 4 minus 2i plus 2i minus I squared. What happens to both I squareds? They turn into, what's I squared? Negative 1. Good. What happens to the 2i and the negative 2i in the bottom? Those are the ones that cancel. So up top, I now have 10i plus 5. In the bottom, I have 4 plus 1 because it was minus I squared. I squared is negative 1 minus a negative 1 is like a plus 1. So 10i plus 5 over 5. What happens here? Yeah, we're going to have some simplifying. So 2i plus 1. All right. This one is actually a little easier. So what's the whole goal? It's to get rid of the i's, right? What type of I do you need to get rid of the i's? I squared. So how could you turn the bottom into an I squared? By I. You can simply multiply top and bottom by I in this case. So the conjugate works if you have two terms. All right, so let me recap. If you have two terms, you got to use the conjugate, right? Because that's how you cancel out the middle terms and you get rid of the I squared in the back. Here, though, we can just simply make it an I squared by multiplying top and bottom by I. So this one's actually a little easier. So I distribute the I top and bottom. So this gives me 2i minus 3i squared. On the bottom, I get 5i squared. What are your questions on this so far? Remember, the whole goal here is to just get the i's out of the bottom. That's why we simply had to multiply just by I. If you multiplied by negative 5i, this would actually work. So if you want to do the whole conjugate on this one, you can. The negative 5's will just cancel in the end. So this just makes it a little easier on you. All right. So in the top, I have 2i. What is this term going to turn into? A negative 1.
Plus 3.
So it's a plus 3. Good. And then what happens to the bottom? You get a negative 5. Good. That's it. What are your questions here? All right, so in your homework, it will ask you to graph on the complex plane. The way you graph on the complex plane is very similar to the way you graph on a regular XY plane. The only difference is this axis we call the real axis, this axis we call the imaginary axis. So it will tell you to graph something like 2 plus 3i. You graph the 2 on the real axis. You graph the positive 3 on the imaginary axis. So you would go over 2 on the real axis. You'd go up 3 on the imaginary axis, and it would be this point right there. And you could label it if you wanted. So again, this part is kind of like your x, this part's kind of like your y, but again, we just call it the real axis, the imaginary axis. I think there's only like 3 of these on your homework, but I just wanted to show you it. So let's practice again. Let's say we had negative 5 minus 2i. How would I graph that? Left 5, and then what? Down 2, good. So that's graphing on the imaginary axis. Any questions? All right, here's your homework. If you guys need graph paper for your complex plane problems, they are over there in the normal spot. Just do the odds. Bring any questions you have tomorrow. Have fun.